we do a lot of winter production of salad greens. So this greenhouse is heated in like March, April, May. It's heated to 60 degrees for our transplants. In the winter, it's heated to like 30, 32 degrees to just keep it from freezing. So we have salad greens in here. So that's what we're here. The heating of this is the problem we're going to talk about. How to heat it. Yeah. So this heated. We're putting in another heated greenhouse that we're just going to be putting in just regular propane heat on, and this one we've got some renewable heat. Yeah. This system is a very complicated heating system. We started out using waste vegetable oil. We had a boiler that burned waste vegetable oil and struggled with it for years, trying to keep it running. I became much more of a heating technician than I ever wanted to be, trying to keep the thing going. It was basically a waste motor oil boiler that you could also use to put waste vegetable oil through. And one of the problems is we're keeping this greenhouse at 32 degrees, and the vegetable oil it congeals. It doesn't flow well at that temperature. I think we would typically, like once we got to transplant season, it would do a lot better. And so we actually, after a few years of that, we just stopped heating it in the winter and only heated it starting in March when we're starting to do transplants. We got rid of that probably 3 or 4 seasons ago. We've got a wood pellet boiler here. It's all set up with a boiler, so there's hot water heat distribution. We also have these solar hot water panels here, and they feed into they feed into the hot water distribution system, and there's some 55-gallon drums that are supposed to be storage for the solar hot water. So the solar hot water, because the boiler.
And you're talking about reaching a set point of not freezing. That's what it's
not
failing.
Freezing during the winter, and 60 from March through May.
And when is it failing? Is it failing at both times?
Yeah, that propane.
Equally?
Probably the 60 degree is the
actually, here would be a question.
60 degrees in March.
60 degrees in March is hard to do. You have like your propane fill, because you're heating this with propane as well. So
yeah.
We could measure the failure of this thing by the amount of propane that you're burning.
So kind of the first question you have to ask is, okay, what are the temperatures I'm trying to achieve inside, and what am I fighting on the outside? What is my heat loss happening? So later this morning. But so you can use these measurements of how cold it is to try to figure out that relationship between how much fuel you're using and how cold it is, to find out what's the characteristic of this thing. So when we're looking around here, let's keep our eyes open for why is heat going away, right? Where's the heat going? What are the different mechanisms that you're losing it, and could you patch those? And then, what you described as a radiator that appears to be undersized. Here, the plastic, the more air you have to move through it in order to keep it inflated. And the more air you're moving through it, the faster your heat loss is, both by air, but also because now you're taking heated air and you're pushing it out. So that's obviously not something you want. Why don't we go in there and see what we have for water storage vessels? Like what are they?
Yep.